Okay, section 15.5, rationalizing denominators. This is going to be something we're going to be doing a little bit. Just kind of going through some examples. To rationalize a denominator containing a square root or a cube root. Basically what's happening is you're going to end up having something that looks like this. Mind you, they're going to be a little bit more complicated. You might have something that looks like, say, that, and we don't want that. We want to get rid of the square roots, cube roots, whatever kind of nth root we have on the bottom, which don't worry, we're not going to be getting into very large powered roots in this course, but we want to get rid of those because again, remember, this is kind of a since this one right here especially isn't a rational number, we want to get rid of those things. It makes it easier to understand. As a matter of fact, I think I say that in this, yeah, right here. The point of rationalizing a denominator is to make it easier to understand what the quantity really is by removing the radicals from the denominators. This is something I'll kind of go through in class a little bit better. But the procedure, if the denominator contains a square root, multiply both the numerator, multiply both the numerator and the denominator by an expression that will give a denominator with no square roots. Pardon me. If the denominator contains a cube root, multiply both the numerator and the denominator by an expression that will give a denominator with no cube roots. Okay, like I said, we're going to go through the examples on these. We'll do one real quick one right now. Very simple. I'll just go to there before we start getting to the next one. 1 second here. Okay, this is going to be very simple. We're just going to rationalize. This is what it means. If you kind of go back, let me change colors here, and remember that what happens whenever we multiply a root, like this one, by another root, they tend to, I'm not going to say the word cancel, but it does cancel the root portion of it. So notice whenever I have 3 over the cube root of 5, well, as it says in our instructions, multiply the bottom by the cube root of 5 again. Okay, and then what I'm going to do over here is I'm going to multiply here also by the cube root. Notice whenever I multiply this cube root by this cube root, you're going to end up just getting a 5. Okay, because the roots cancel. Up here I have a 3 multiplied by the cube root of 5. That's as far as I can go with that. So this right here for this one would be the final answer. And notice we have now removed the radical from the bottom. Okay, and don't worry, we're going to go through a few more examples. There's going to be a few more videos. We'll do some examples in class, and then there'll also be some more extra notes. So you're not just going to run into cube roots, okay, like this. You're going to run into some simple expressions too, okay? So notice here, if the denominator of a fraction contains a sum or difference, subtraction, involving a square root, rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. Okay, don't let that word scare you. Conjugate. Do not think of this as inverse though. So let me get in here and highlight some. Let's change this to a different color. We're going to do this conjugate of the denominator. Notice here, if the denominator is of the form a minus b, okay, the conjugate is a plus b. We're just changing the operator symbols. Here, if it's a plus b, you're going to multiply by a minus b. Okay? The new denominator will be a difference of 2 squares and therefore will not contain a radical term. So let's do an example real quick and you'll kind of see what I'm saying here. We've got y over the cube root of 5 minus 3 multiplied by the cube root of 7. Okay? Sounds like a bunch of junk. Okay. Let's come in here, be very careful, be very intentional. Do this step by step. First off, always, let's go ahead and just rewrite it. We have y all over the cube root of 5 subtracted from 3 cube root 7. Notice I have right here, let's see if right here, I have the operator, the subtraction operator. I need to multiply everything by its opposite, okay? I need to multiply this part here by its conjugate, not inverse. Don't think inverse. Inverse is what happens to these guys, and inverses of everything is, it's not what you're thinking, okay? This is a conjugate. We're just changing the operator. So whenever I rewrite this, I can write this as multiplied by, okay, the square root of 5 still, But instead of this subtraction, I'm going to have a plus 3 cube root 7. And then also, I'm going to do what I do to the bottom. I got to come up here and do to the top. Okay, so far so good. Now notice here, we'll worry about the top. I'm going to multiply this y. Now, I could multiply everything by y if I choose to. Okay, so we'll go ahead and do that because a lot of people are going to want to do that. So if I multiply, remember that's the same thing as if I put a parenthesis around that, and that's just distribution at this point. So I would have the cube root of 5 y, if that's where you choose to put it, plus 3 7 y all over. Notice it says now we're going to have a difference of perfect squares. Okay, difference of perfect squares is going to be a squared minus b squared. So I can literally write everything as cube root of 5 squared minus 3 cube root 7 squared. Well, as we've learned, what is the inverse of a root? And that is the power of the index. So since this is a square root, that's going to have an index of 2. So if I square everything in here, that's going to remove the root. Now for here, notice here it's going to remove a root, but then I've still got to square this 3. So let's come down just a little bit and I'll kind of keep the writing process going so you see what's going on. Okay, I'll keep all the top the same. I'm going to move my y though to the front because I kind of like it better there. That's just me personally, because I do know that that's going to be some sort of number at some point in time if I solve for it. And then even here I can put 3y cube root 7. Okay, all over. Well, notice here, this is just going to become 5 minus, well, that 3 squared is going to become a 9. When this cube root gets dropped out, I'm going to have 9 times 7. Okay. When we work everything out, just go ahead and get your calculator just in case. I am a stickler with that. I always like to double check. We're going to get negative 58 because you're going to have 5 minus 63, which is going to give us a negative 58 on the bottom, all over this y cube root 5 plus 3y cube root 7. But I don't want to have that negative kind of floating out there on the outside, so I'm going to pop it out front, put everything here inside of a parenthesis, plus 3y cube root 7 all over 58. Okay, and if you do it just right, excuse me, on Hawks, if you put the negative like directly out front, you should be okay. Sometimes when writing, I don't want to make it look like this guy floats to the top, or maybe it accidentally in Hawks does that. Putting that parenthesis kind of protects me. So, but there'd be your final answer there. Like I said, plenty more examples going to be in the homework. We'll do them in class. So there we go.